Hello there. Today I'm going to show one interesting task about trigonometry, and it is find the value of multiplication of all the elements from n equals 3 up to plus infinity. This means plus infinity of 1 minus tangent in the fourth power of pi over 2 to the power of n. Okay, let's try to evaluate it. Firstly, let's try to recompose it. Um, we wrote it outside just to work with it without multiplication digit, and I would write it like x, just to do not care about it. Pi over 2 to the power of n, it's base, but x is good. After I will make substitution, but before let's work with it. Okay, tangent is sine over cosine. Let's do this. And you can see one distinct thing that there we can get cosine in the 4th power minus sine in the 4th power. Uh, because wait a minute, because like this, and then you can ask me what do we do next. Okay, let's suppose it is a, it is b. A minus b equals 0 when a equals b. It means it can be divisible by a minus b, because thinking about it as about polynomial, thinking a is an argument and b is a constant. um, A equals b is a root for every b. That's why it is divisible for every b. Yes, it is difficult, that's why I also tried. And of course, you can divide it. But how have we got there? We got cosine minus sine, and the cosine the third power, sine third power, but wait, look here. Cosine the second power, it is 1 minus sine in the second power. But then sine cube minus sine cube will cancel, the same with the part. That's why this is nothing else than just cosine plus sine. I'll show. Like that. Now you can see it can be cancelled, because seriously left only sine plus cosine, but the sine cube minus sine cube, cosine cube minus cosine cube, and cancels. It cancels, and we can obviously see that it is cosine square minus sine square, which is cosine of 2x, as I said. Okay, let's try to plug it inside and go next. On the next step, I will note that it is something very interesting. The same multiplication digit, but now the products are more interesting, because we can really see it is cosine with the fourth power of series, yeah, 2 to the power of 3, 2 to the power of 4, and so on. It is something beautiful, isn't it? There, the same thing works, but of course we have no fourth power, but it is multiplication digit. You can move this fourth power out of the product, charge with it, and use the first power then. But there it is the same thing, but from 2 up to infinity. Because seriously, the only thing changed for infinity is large L. For example, later change it cosine of 2p over 2 is the power of L. But if L is enough big, it is 0, but cosine of 0 is 1. And our difference will be just like our golden number multiplied by 1 is another golden number, which is our destination. That's why I don't care about this. There's nothing. Let's just calculate it. I wrote it to make more visible, something like this. Okay, we can see that we have to find a product from something up to infinity of this thing. Okay, let's try to figure out what is this. Product from A to B of this thing is something like that. 2 over A, 2 over plus 1, and so on, up to 2 over B, over the power of B, sorry. What can we do? We can multiply it divided by sine of pi over 2b, and then we'll get the 1 over 2 multiplied by sine of pi over 2 at the b minus 1 power, and sine goes with this sign, something like somewhere there, and goes so on, so on, so on, up to this part, this term. And then we will have what? Something like this. This both changes goes into sine of pi over 2 b minus is about b minus 1, and so on. And then just like this goes, I mean this goes up to 2 terms left only. This 2 gets some power, and we are left with sine of this small angle. And let's go next step, just make it sine of 2 to the power of a minus 1 in the denominator and pi in the numerator, and there b minus a plus 1. But seriously, this angle is enough small because b goes to infinity. That's why we can use the perfect rule of the limits and just clear the sign digit. Clearing the sign digit, we will left something like that. Then we just look at our task another time and use our new method, and we'll see that it is really trivial. It is 4. Yes, pi over 4 is 1 over square root of 2, and this is pi over 2. Sine will be simply 1. There we'll get 2, there we'll get 4, and so on it goes, and we will left with pi cubed over 32. And yes, I'm right, it is pi cubed over 32. And this is the solution.